Okay, so intake system. Let's talk about filters real quick. And this, we're talking about the air filter, but a lot of what we talk about here pertains to hydraulic filters, to engine oil filters, to fuel filters, et cetera, okay? They're all rated by a micron, right? And 1 micron is actually 1/1,000,000th of a meter if you want to. There's going to be a test on that later too, by the way. Okay. Most of your fuel filters, your fuel system has, most of them have at least 2 filters on them. The first one is called a primary filter, and that is going to run maybe 10, 15 micron range. That's basically get the big chunks out, okay, of the fuel, any debris or rust or whatever. Typically, and I always recommend it, I've actually retrofitted a lot of fuel systems to do this. Your primary filter should also be what is called a water fuel separator. Basically, that's going to work like a centrifuge. You have fuel coming in, the way it's designed, the fuel spins around in a circle. Water's heavier, right? Gets thrown to the outside of the filter, drains down to the bottom, fuel goes out to the next filter. All right? We have a little drain on the bottom, we can undo that, and we drain out the water, turn it back up, life is good. There's no bleeding in the system, no draining fuel, no nothing. Right? Water's heavier, it settles down. So that's a water fuel separator. Typically that's on your primary filter. After the primary filter, we're going to have our secondary filter, sometimes referred to as a final filter. Most of your final filters are going to be between 5 and 7 microns. Most of your manufacturers, excuse me, for new engines that have a high pressure common rail require a 2 micron final filter. That is tiny. Absolutely tiny little holes. Water will plug a 5 micron filter, so darn well it's going to plug a 2 micron, all right? All of the bacteria or that's running around that fuel because we haven't treated, that will plug the filters, okay? We haven't added a pour point depressant, so we got those wax particles together, that will plug your filters, okay? So in those instances, it's really got nothing to do with the filters. It's because we didn't do what we should have done with the handling and the processing of the fuel, okay? I always cut open my filters, all right? And this is something that I would highly recommend you tell your ag producers to do. And I didn't care if it was gasoline or diesel, if it was engine oil, if it was fuel, if it was hydraulics, I really didn't care. I cut them all open. Now, a couple of words of advice here. Number 1, put on the gloves, all right? Because you're going to get that crap in your hands that just goes right in your bloodstream, not good. The second thing is, what I actually used to do was when I was cut them open, I put on my rubber or my nitrile gloves. I'd also put leather gloves over the top of them because those spin-on filters are steel. You start cutting steel, you got sharp edges. You slice your hand up and you get that used oil in your hand and that cut, that is not a good thing. That's really, really bad, okay? So safety, all right? I just use an air chisel. You can buy I'll show you a tool when we go to Farm Mechanics. We got a Caterpillar one. You can buy it for $150 if you want. You can just use an air chisel. I just use a damn air chisel. Okay, and it's zzz around, pull it apart. Then you start looking at the media, which is a filtering element inside that canister. It can tell you a lot of stuff. Okay, number 1, if you have bacteria in that fuel, you'll actually smell it before you see it. God, that stinks. Oh, it's rancid. Okay. If there's green slime, that means you have live microbes in there. If it's black slime, it's dead microbes, all right? If the pleats are wavy, you've had water through it, because most of your media is going to be some type of a paper fiberglass mix element. And if they're wavy, it's water, well, water makes paper wavy, right? So the media will get wavy, okay? If it's really, really black, that probably means low quality fuel. It's got a lot of ash in it. And ash is another good way to screw up an injector. And your valves and your turbocharger and all that good stuff, okay? Again, then that would be something that you look at on, excuse me, the spec sheet from the suppliers, how much ash is in that fuel, okay? So you can tell a whole lot from that fuel. On an engine oil filter, you can also pull that media apart and you look right down that crease in the bottom and you're looking for metal. If you find metal in there, you'll probably always find little fines in there. You find chunks of metal, that's not good, okay? number one, the filter's doing its job. All right, it's trapped the metal, but number two, we need to figure out where the hell that metal came from. All right, we'll talk more about that when we get to our lube system. Nicole.
So what do you think about, cutting open a filter versus sending in oil samples to?
Oh, we're coming to that. Oh, yes, my dear. We're going to hit the heck out of that one. Oh, yeah. That's all right. Yeah, I'm a proponent of both. Huge on the sampling, absolutely huge. Yeah, we're going to spend some quality time on that one. Thanks for bringing that up. Yeah. As I said before, some filters, the only reason I would buy them would be for target practice. I sure as hell wouldn't put them on my engine. All right. One thing that I told my customers is, especially if you're dealing with any type of an engine that's under warranty or a transmission or whatever, you go with OEM. If it's a Caterpillar transmission, it gets Caterpillar filters. If it's a Cummins engine, it gets Fleet Guard filters. Okay, Fleet Guard's a subsidiary of Cummins Engine Company. All right, go with OEM. Because trust me, that John Deere combine, the latest and greatest John Deere combine, the engine is $98,000. And if I went to Walmart, if I could, and I like Walmart, it's okay, and got an oil filter and slapped on that John Deere engine, and there was an engine failure, I guarantee you there's not going to be a warranty on that engine because I used the wrong oil filter. All right? And that is absolutely critically important. You're dealing with some very, very expensive pieces of machinery. Right? And to go to Walmart and get a $10 filter versus go to John Deere and buy a $60 filter, I'll truck out to John Deere every day, including Sunday. All right? So back on the warranty, it's a huge issue. So just go with the OEM. Okay. When you're outside of the warranty issues, they need to be pretty particular about what filters they are going to buy. When we go down below, I'll show you, we have a bunch of filters that are cut open, and on the outside, it just looks like a steel container. But on the inside, holy cow. I mean, it's just night and day difference between the different brands of filters. It really is. Okay. So that is a huge return. We're talking about efficiency and return on your investment. Oil filters sound pretty mundane, or a fuel filter or a hydraulic filter. That is a huge return on your investment. It really is. Okay. So on our intake system, basically my discovery of knowledge when I was in business is that my customers and your ag producers change the air filters way too often. Why? Because they think it needs change. They have no justification why the hell they change, just because it needed changed. The good air filter is going to set you back $100, maybe $200 by the time you get the main filter and the safety filter. All right? You guys ever heard of a filter minder? You guys ever heard of one of those things? Okay. What it is, it's basically, so how can I explain it? So a turbocharger is going to suck the air into the turbo, right? And it's going to compress it, and it's going to put it into the intake. So from the air filter to the turbocharger is under vacuum, right? Or it's under less than atmospheric pressure. So the filter minder is going to go somewhere between the air filter and the inlet of the turbo into the compressor side. So what it's going to do is that air is going through there. It's going to, so it's a little plastic clear housing about yay big and about yay, probably about yay round. And it pulls a vacuum on it, and it has a little spring-loaded gauge. And there's clear, and there's yellow, and there's red. And when that gauge gets all the way down the yellow, all you just do, you look at it, oh, we're in the yellow, we're fine. We don't need to change that filter. So you run your whole season, and it's still looking good, yeah, we're fine. Gets down to the red, we probably should think about changing it. Gets further than red, yeah, we better shut down and change that filter. That's the only time you ever need to open up that air canister, ever, is to change the filter, okay?
And those are pretty easy to pick up.
Oh yeah, absolutely, yeah. Most of your parts houses have those, yeah. A lot of it's actually probably standard operating equipment now. Most of your engines come with them on there, yeah. Yeah. I know we have one in my semi across the street. I'll show you what it looks like across the street, yeah. Real easy to install, yeah. It's just typically you're going to have some type of plug somewhere on the air canister, so you just take it out and screw this in and seal up, and life is good. Yeah, they're pretty straightforward. And I'm a huge advocate of those. So a couple of issues with our air filters, if we were changing it too often, number one, we're wasting money, big time, all right? And number two, every time I take that air filter out, I still have air going into that engine, right? Even when the engine's not running. And 9 times out of 10, we're not doing this in a shop, are we? We're doing it out in the big blue sky garage where there's a little bit of wind and there's a little bit of dust. Where's that dust going again? Into the engine, right? It takes 8 ounces of dust to totally dust a diesel engine. 8 ounces is not a whole lot. Now, it doesn't matter if I dump it in right now or over 10,000 hours. So the less I can expose the internals of the engine dust, the better off I'm going to be. So why the heck would I need to change my air filter more than what I need to? Okay? Return on investment. Okay? A lot of people waste a tremendous amount of money just by changing the damn air filter too often.
So what about taking the air filter over to the air hose and blowing it
Oh,
out?
let's talk about that. Okay. Short answer, no. Yeah, and a lot of people do that. They really do. So we talked about that micron rating, right? So we take this air filter over to our little shop here. We've got 135 people. Oh no, we're 140 because we're big time farmers. Okay? We blow the living crap out of that. What just happened to my micron rating? With this big ass hole in there right now? Okay? Which incidentally isn't going to filter anything. All right? So you see what I'm saying? And I've had customers who wash them and reuse them. No. So why'd you pull that? What needed changed? Well, how do you know that? Well, I just did. So I'm going to wash and put it back in. Well, why don't you go and spend $50 and buy an air filter minder and just change it when it needs it, and just burn the damn thing when you're done. Ooh, I didn't think of that. Well, let's talk about that. So yeah, this thing of air, and I guess a lot of people, they will not buy off. They still have to blow it off with air, but let's bring that pressure down to like 10 psi. Full blast shop air is a really, really bad thing. It really is. I've seen a filter get totally destroyed with that. Yeah. So low, extremely low air pressure will get some of the dirt out. And always blow from the inside out. I've had guys who blow from the outside in. Well, that's just forcing the dirt through the media. So now my teeny little holes has went to big holes. Okay, so I'm just not a proponent of air. Good question. Turbochargers. Standard operating equipment now. I don't know if there's many naturally aspirated. So naturally aspirated means there's no turbo or supercharger. Turbocharger is going to run off of the heat of the exhaust. The heat of the exhaust will spin a turbine, and on the other side of the turbine is a compressor wheel. The compressor wheel basically takes this much air and stuffs it into this area and shoots it into the intake. So we're compressing the air, so now I can get more air into the combustion chamber to burn the fuel. Okay? Back in the day, we just had a constant turbocharger. We just ran it, there was no, just basically ran at one speed. Okay? Then we come on to a wastegate. When a turbocharger spools up, when it gets up to RPM, we have what is called turbo boost. That's how much air pressure is going into that engine. Now, I'll show you our engine dyno over here. And the engine that we have on there right now is a C15 Caterpillar. It's about just a little shy of 500 horsepower. And when we put that under full load, we can push up towards about 45 to 50 pound of boost. Okay? The issue with that is, you've heard the adage that the failure of a chain is the weakest link, right? Well, the weakest link on most of your engines is going to be your bottom end. So if I have too much boost on top of that piston, I'm going to start breaking pistons, breaking connecting rods, breaking crankshafts, etc., etc. So this one was basically ran off of vacuum. So when I get to X amount of boost, as per the application of that engine, we'll just stop dumping the turbo pressure. So it's basically a safety mechanism, as it was, okay? These two here, we have a term called turbo lag. In order for the turbocharger to work correctly, we have to have heat coming off the exhaust. In order to get heat from the exhaust, we have to burn the fuel. In order to burn the fuel, we have to get a lot more air in there. In order to get a lot more air in there, we have to get the turbo to spool up. In order to get the turbo to spool up, I have to get heat from the exhaust. You see how that vicious cycle keeps going? So until that turbo gets getting with the program, then we will have some turbo lag, all right? This took care of that. That is a variable geometry turbocharger. And that is actually part of our emissions management system. The VGT is what it's called. It actually has, excuse me, movable vanes that are electronically controlled. So now we've got some electronics involved in this, or the ECM. And it basically changes the pitch of the vanes so that as soon as I stomp on that, because of the pitch of the vanes, I get immediate turbo response. So that thing spools up really quickly, all right? When I spool up, you know, some of these big turbos are running at 250,000 RPM. That's like tremendously fast. So I think is the next slide, we're on 5. Oh, okay, I'll get it right here, excuse me. When I have something that's running at 250,000 RPM, and I have a chunk of dirt go through it, that is not good, okay? This is the type of thing that happens. This is a compressor wheel. So this here, see these little chunks right here that kind of flailed off? That's the compressor wheel that's compressing the air. Where is that air going? Into the engine. Where's those chunks of metal going? Into the engine. You want to talk about a pretty poor return on investment? Let's talk about that. Okay? So now we're back to our filters. Quality filters. You get rid of all that debris or whatever and make sure that nothing like this happens. Okay? And I have seen this more than once. This one here is actually a result of oil. Okay? The lubrication system also sends oil to the turbocharger. So this shaft here actually has another wheel on this side. It's in a housing. So this side here is going to have a wheel where the heat from the exhaust gas spins that over. This side here, so that's the turbine side. This is the compressor wheel. This compresses the air. Right in the middle, because of this shaft, I have a bearing, which is lubricated by engine oil. If I have dirty engine oil, we're not going to lubricate that shaft. So the bearing is going to fail, and this ends up rubbing on the housing. But where did that metal go again? It all went to the intake of the engine, right? So now we're going to start toasting valves, heads, tips of injectors, pistons, piston rings, piston lands, and every other gosh darn component that's in there. So now that $98,000 engine on my John Deere combine, whoops. Now, I'm not just talking one cylinder either, because that air goes to 6 cylinders. How many fingers? All right. So we've got some issues. Okay. So now we're back to our lubrication system to kind of take care of the turbocharger, which is tied in with the air system, which is tied into the fuel system. So here, these systems start coming together. Okay. Aftercoolers and intercoolers, pretty much standard operating procedure. An aftercooler, they both do the same thing. As soon as you like, our engine's compression ignition, right? We squeeze the living crap out of air, we superheat it, we put some fuel in, and we light the fuel off, right? From the hot air. So turbochargers are the same thing, a little bit different. When we compress that air from that compressor wheel, it also superheats it. We do not, what the purpose of a turbocharger is to put more air into the cylinder. Well, what happens when things get hot? They expand, right? So what's the point of compressing air, getting it hot, expanding it, and then dumping it into the cylinder? We're kind of defeating the purpose. So what we're going to do is we want to cool off the air, all right? And that's where we're going to use either an intercooler or an aftercooler. Aftercooler is typically found in front of your radiator. Right? It actually does look like a big old radiator, is what it looks like. And that's called a charge air aftercooler. So all we're doing is we're just putting like road air or field air, whatever, across that, and it's going to cool down the air from the turbo before it gets into the intake. Okay? So now we're putting cool, dense air into the intake manifold, goes into the cylinder, now it can more completely burn the fuel. Okay? An intercooler does pretty much the same thing. The difference with an intercooler is it's basically a housing Inside the housing, I have a little radiator. And that's run, we have engine coolant running through that radiator. So it's completely, constantly cycling through. We push the air from the turbocharger across that radiator, cools it down to engine temperature, then dumps it into the intake. All right, so both ways we're getting cool air into that cylinder. The only disadvantage, well, a disadvantage of this one is that in wintertime, we can actually get that air a little bit too cold. If I get the air too cold, that's going to lower the temperature inside the cylinder, which means I won't completely burn the fuel. Therefore, emissions go up, miles per gallon goes down, or hours per gallon or whatever, power goes down, because I can't completely burn the fuel. All right? So that's why you see a lot of semi-trucks around wintertime have the big old winter fronts on. Okay? That's why. We don't cool the air down completely. Okay? The disadvantage of this one is that I can't, this one here is kind of dependent upon my cooling system. If my cooling system is up to snuff, my radiator cap's good, I'm all sealed up, and I've got the correct coolant, the correct mix, blah, 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 then it will cool the air down to the operating temperature of the engine, 200 and something degrees. All right? But if I'm overheating my engine, I will never cool that air down. So I'm going to be putting hot air into that engine, which is going to kind of compound on itself. All right? So there's advantage and disadvantage. This is pretty much what most of your ag producers are going to be having, is this one right here. And I'll show you on the tractor when we get over there where that's at. Okay?